This is going to be the start of another series of videos on a new boat I have designed called the Electric Moto Craft. It's going to be a 14-foot, kind of either a decked or open with compartments on the end, kind of a kayak, kind of boat. It's going to have about 34-inch beam on it. We'll see what it comes out to be when I finally get it all laid up. But one of the things that I wanted to do on this design, and I will be having, as a sidebar, I'll be having a model posted on Duckworks in my section of the plans part that you can download it and make the model. I'm going to try to do it with colors. So if you have a color printer, you can print it out and your boat will have some pretty colors to it. But one of the things I wanted to do on this boat, which I did in the plans, the original set of plans, when I started doing the lofting, I thought, okay, how big a piece of plywood can I make this out of? And I discovered that if I go back in to the original plans and narrow up everything just a hair, and then move the panels closer together so that when you're cutting out between the upper and the bottom, because this is only going to be 4 panels, 2 on each side, and then the stern panel, that I could get all the parts out of a 2-foot wide section, around 14 feet long, give or take an inch or so. So if you want to, you can either have enough left over to put the deck on out of the same material, or you'll have enough material left over that you can make 2 boats out of 4 sheets of plywood. Or if you cut 2 sheets in half and scarf them together and then stack them for the lofting cutout, then you'd be able to make 1 boat out of 2 full 4x8 sheets. But one of the things I wanted to get into was, in order to keep from having to break a sweat all the time on scarves, and the thing I didn't like about scarves was with thinness of the plywood, that upper and bottom lamination on the surfaces of the 6mm plywood you get is more decorative than structural. But if you've ever studied beams, the strength of a beam is in the upper and bottom surface. That's why you'll see buildings made where the roof is supported, or houses are supported with 2x4s, either held apart by crisscross grids of metal tubing, usually electrical conduit tubing, or there'll be a thin little web member down of the oriented fiber wood. Basically, the strength of a beam is in the 2 opposing surfaces. So when you scarf wood together with that bevel on 1/4-inch thick 6mm plywood, you're going to have a 3-inch scarf for a 12-to-1 ratio. But the problem is it's almost impossible. I have never achieved it yet, scarfing as careful as I try to be, to where the top surface of one comes out perfect, to where you have a full width and thickness in the bevel along the breakout edge of one piece to match the part on the other one. They're always ragged edges, and when you glue them together, you'll see that I always put a strip of fiberglass along that joint on both sides, because the 2 pieces of fiberglass are going to be offset because of the toe outs are offset from each other. But if you didn't do that and you put some pressure on that plywood, it's going to snap. It always snaps. I haven't had one fail or survive yet that didn't fail along that line, because it's almost impossible to get those 2 edges, the very surface and bottom edges, to match up with their counterpart on the other side. Now, if it's a solid wood, then there's no problem. You've got a lot of extra to work with there. But you get in those little thin sheets, you can't do it. So what I'm doing, and I just got done practicing, was to make finger joints. We're going to do that. I'm going to on this segment, I'm going to get into epoxying these things together. I made a plate. I got a shop box 1/2-inch finger plate, and they're about, I don't know, 1 inch and 3/4 in. So and then I got it mounted to a real thick piece of wood. But the thing I had to do was go out and buy 2 new bits. One was, I believe they're both 5/16. One was an upcut spiral, and the other one was a 5/16 just straight cut. Even though this is a 1/2 inch, I put my gaps. I put my 5/16 router guide, the little round hole that fits, or the I'll show you later, that goes around here. It's if you try to put in the 1/2-inch router bit itself and do out the hole, it just binds up. But if you go in with the little up spiral first and kind of make a path, and then you can come back in with the 5/16, just straight-sided router, and it cleans it out. And there's plenty of area for the waste to go away and not get jammed up inside the router and the bit and the edge of the wood. So I've got that in, and I've been trying to figure out how to make certain, make sure that the edges are going to be matched up here, where you got a flat edge where you can put a straight edge on it, and it's fairly accurate. So I know how to do that now. It's part of the layout, is be able to offset one from the other by a 1/2 inch. Also, when I go up to set this, since this is only a certain length, I'm going to have to lay out the plywood, the ends, and then put in a straight edge clamp down either side that this will slide along, and then I'll get some doweling or whatever to make some pins to hold it in place from the ones I just set. So I know that it'll always, because they have that strong back in here, it can't move this way or that way. As long as it's pressed up against that and clamped down, it can't go anywhere. And I've got some extra holes in it here so that I can put some wood screws through into the part that I'm going to be routing, so it doesn't shift around in relationship to this. So I'm happy. I'm really happy with the way this came out, and I think by the time I get done epoxying it together, it's going to be fine. It's going to be a nice strong joint. I will go ahead and probably put 5 inches of 4-ounce cloth on either side. I may try that with or without on this experiment and see how bad I can, or how much I can bend it. I'm expecting good results with no breaks, because the fibers go all the way through onto these fingers, and there's not any kind of like other joints right in here, but all these things are going to be locked together in one big piece. So as I keep on battling here, we'll go on and do something else. I'll come back later with when we epoxy up the edges, because I'm going to have to seal off the cut spaces here first with a little bit of just straight mixed epoxy, so that they fill up the voids. And so when I do put the last gluing part in, all this edge grain doesn't suck away all the epoxy from the edges, and I get a dry joint. So we'll come back. Okay, here is that up spiral router bit that I was telling you about. You can see how it twists around, and as it comes around here, it just chews the wood up and then just leaves a nice clean path in behind, and squirts all the dust right straight down on this one. When I'm coming on top, the dust goes straight down to the floor. So there's also this is an up. They also have a down cutting spiral bit, so the stuff must go the other direction on that. And then the other bit I have is just a regular straight-sided 5/16, which fits in my guide set. This is my guide set, and it comes in, like, the biggest one's a 1-inch outside diameter, and then the smallest one is a 5/16 outside diameter, but you'd have to use that with special bits because of the size of the shaft of most router bits won't go through the opening on this little guy. The small shaft routers will go through the 3/8 and up, but you'll be changing bits when you do that anyway. I mean, this was a worthwhile addition, and I was able to find a base plate from my old Sears router, my old Sears commercial, which must be close to 40, in the upper 40s year old. It's the 575B model, and it does fit those old Craftsman routers, even though it doesn't say so in any website you come across. There is 3 holes that do line up with that one. So we'll come back when we start epoxying some of these things up again. Well, I just wanted to tilt back more here, to do a little bit of finish work on this finger joint. I glued it up. I did like I have before. I put down some clear plastic tape on the lower side when I got ready to put in the epoxy to join the two of them. But I'm noticing that this time around I had some adhesive from the plastic tape that was sticking to the wood, but it's sanding off fine. But I don't know if you can even see them in there, yeah. The fingers came out pretty good. I got a little bit of, some gaps in here that didn't want to go in. It's the same. I need to figure out how to, to push them in. I found that when I had pre-soaked the edges, I had to come back in with some doweling with a little bit of sandpaper around it to sand down those rough edges that were, the fibers would stand up after they had that epoxy soaked in them. So I had to cut those down with sandpaper. But it's going pretty good. Now I'm going to go cut this into strips. But right now I don't know if you can see it. It's holding the. I hear some cracking in it. I don't know exactly what it is, but it's bowing good. I'm going to cut it down into some test strips and break them to see how it breaks. I think this will be my new joint. I won't do the bevels anymore. I'll strictly go to the finger joints. I think I will get a much better joint, and most likely persons, any of you builders out there doing, your first boat or whatever, this might be easier, especially if you have a router and you don't want to go out and buy a $100, $200 big long A7 or A8 plane. So let me go cut these back, or cut them in half, and we'll cut back. Okay, I've got, this is the worst piece, and I want to see where it's going to break at. These weren't even clear, full fingers. Okay, it breaks around where I thought it would. But then again, this is the one that didn't have the full fingers. No! Let's try this one. I can see a little bit of pulling along in here where I didn't get a good fillness with epoxy. I won't use this straight mixed epoxy anymore. I'm going to go back to using Gel Magic for this thing. But okay, let's see how it bends. Okay, I've got the same thing, only a lot easier with the just the regular bevels. Yeah, that's a springy. I don't know if you can see. Yeah, I guess you can. That's quite a bit of flex there. And I'm pretty sure that this was also caused by not having enough, where am I at here? Epoxy in the ends. They're dry. So if they had been attached in here, it would have held, but I think I got a lot better joint than I would have gotten with the bevels. This one has a lot more epoxy in the ends. Okay. But not enough. Okay. I was doing a little snapping along the edges here. They will break along the epoxy line, but then again, I wasn't using the right stuff. I should have used the Gel Magic. I think it would have worked a lot better. I'm almost wonder if maybe a slight bevel along the edges here to where I can lay in a bead of epoxy. It'll just kind of float in. But I'm not going to worry about that. For the flexing that this was doing was way more than the hull ever did. It would take us quite a whack, and I was impressed with the bendability of this before snapping, which I wouldn't have gotten. My regular scarves would have snapped before then, like I explained earlier, because the surface, I couldn't get the surface areas to match up on either the top or the bottom, especially the tension edge, which would be on the top or whichever side's being flexed outward. So on with that, and I'm going to go get the next thing coming up will probably be tank testing on the model, and then by the time I get done with tank testing and that, I should have the cover letter and the model ready to send the Chuck down Duckworks, so you guys can go ahead and download and build your own boat. So, see you later.